Hello, everyone. Welcome to this video lecture. All right. So in today's video, we are going to go through exam 2. All right. So we're going to firstly cover the exam coverages. We will go through every single topics that will be covered by exam 2. And then we'll go through some homework questions. All right. So let's get started. Firstly, let me share my screen. All right. So here we go. And this is start with chapter 4, section 4, which is the Bayes theorem. All the way, well, might be here. Okay, here we go. So this is the section 4 in chapter 4. The exam 2 start with this one. Okay, sorry. Start with this one. Okay, so let's go this way. All right, start with this section, Bayes theorem. All right, so let's move on to here. So firstly is the law of total probability. So here it is a partition, right? So B1, B2, Bm is a partition. Then for any given A, we have the following formula. Probability A equals this one. All right, so some typical examples. All right, so remember this one, 3 species of birds on the island, yes. And so this one, right? So B1, B2, B3, it is going to be a partition. And then the probability that is going to be tagged, P of T equals P1, T1 is equal to this one, 0.3, 10.2, 0.5, 10.1, 0.2, 10.6, 0.23, right? So this is a perfect example for the law of total probability. Okay. So we also have another example for the law of total probability, right? So this is the effective products. Okay, so B1, B2, B3 is a partition, and the law of total probability that is defective is, all right, a law of total probability. Plug in everything, we got, this is a 0.0245. Yes, all right, so this is definitely you want to know what is the law of total probability. Now, once we have the law of total probability, we can go over the Bayes theorem. All right, so as you can see, so if you want me to consider a partition of this one, then we have the following. This is called the Bayes theorem. All right, so probability BK given A, all right, equals this formula and so on, right? So here is called the posterior probability, and this is the prior probability. And okay, let's consider this one, right? So this example again is about 2 machines, 30%, 70%, all right? So of the products respectively, and 2%, 3% of defective rate respectively. And then a finished product is randomly selected. What is the conditional probability that it's produced by B1, given that it's defective? So in other words, we want to find this probability, right? So now probability B1 is 0.3. And without any condition, it is 0.3. It's a prior probability. Now we are given some known information. Right? It is defective. So under this condition, what is the probability that is made by B1? So this is going to be called a posterior probability. How to find this posterior probability? Bayes theorem. Yes, Bayes theorem. Now let's consider this one. Okay. So we got this one, right? So it's probably B1 given D, and on the top is the product row. On the bottom is the law of total probability. Okay, so we found this one, plug in, 0.222. Yes, 0.222. Okay, so this is Bayes rule. All right, that's the Bayes rule. We can also solve this one using the table if you want. All right, using the table if you want. All right, assume there's 1,000 products. So build this table and complete all these ones based on the information you have. 30% by B1, 70% by B2. So we got 300, 700, 2% rate. Defective rate for B1, 3% for B2. So you have 621. This is 27. And you finish all this one. Once you complete the table, then you can only focus on the defective ones. There are 27 of them, 6 of them are made by B1. So 6 out of 27 is 0.222. So this is using the table methods, all right? So either way, okay, you can directly use the Bayes' theorem or use this table. Either way works, okay? So, okay, here our favorite example, birds, right? Space is a bird, birds. Okay, so B1, B2, B3 is a partition, right? So therefore, based on Bayes' rule, probability B2 given is tagged using the formula, we got this probability 0.207, 217, 5 over 23. They are just equal. All right, so in this one as well, right? So B1, B2 is a partition. So by Bayes' theorem, probability that is made by machine B3, given it's defective, is given by this guy, 0.204. You got it. All right, so this is the Bayes' theorem. Now, again, well, this example is very interesting, right? So it's about the 1% prevalence rate for the screening test, right? So this is also a very interesting example, all right? Okay, so that's about the Bayes' theorem. You can also use a table to solve this kind of problem. But anyway, so that is Bayes' theorem in section 4.4. Yes, all right, so we're done with this one. So make sure that you understand what is the law of the probability, what is the Bayes' theorem, how to use them, right? The table method or the formula, either way works. Okay, so that is about section 4.4. Now let's move on to chapter 5. Okay, so section 1 is about random variables. All right, so here, what is the definition of a random variable, right? So it is a random variable. It's a random variable. Yes, random variable. My goodness. So here we go. All right, so it's a random variable. All right, denoted by a capital letter. It has this one, it has a numerical value of each outcome in the sample space. So be aware of these random variable and the possible values. As you can see, some more discrete, some more continuous. So we have definition for discrete random variable and continuous random variable, right? So, all right, here is going to be the probability distribution of a discrete random variable. Okay, so gives what? The list of possible values x and the corresponding probability values. All right, so you have the possible values of this random variable, and also you want to find the probability values as well. So for this example, as you can see, right? So the possible values is 0, 1, 2, and the corresponding probabilities 1/4, 1/2, 1/4. So this table is the probability distribution of this discrete random variable. Very good. All right, so next is the probability distribution, right? You need to make sure that they're all numerical values. They're between 0 and 1, and the summation is 1 or very, very close to 1, right? So due to a rounding error. Okay, so we also give this example. Determine if these are valid probability distributions. Guys, you know what it means, right? So this is easy. Okay. And then this example, right? So rule of Faraday twice. X be the maximum value of the two rows. The sample space of this random experiment is, all right, given here. And what are the possible values of X? Right? So possible values will be 1, 2, 3, and 4. Yes. And find the corresponding probabilities, P of 1, P of 2, P of 3, P of 4. You got all these probability values for those possible values of X. All right, so I got that. And then the table, the distribution. You see, this is very good. All right, so you have possible values of x and have the corresponding probabilities of x. That's awesome. I love it. All right, so probability x is greater or equal to 3, p3 plus p4 equals this guy, and as is odd number, p1, p3, that's this one. So given for this example, right? So we first we figured out the possible values of x, and then we got their corresponding probabilities. We got their table, right? And then based on this table, we figured out these probabilities. How wonderful is that? I love it. Okay. Also this one, yes. So x be a random variable with the following probability distribution. You want to find the value for c. 0.1, 0.2, 1 over 2. Okay, so you need to find the value for c. How to find the value for c? Because what? The summation must be 1. And so for c, you got that. All right, just to be careful, the total probability should be 1. All right, so then you can solve for c. Second section, 5.2, section 2, the mean and the standard deviation of a discrete random variable. All right, so now x is any discrete random variable, then the mean, all right, by definition, is the sum of x, p of x. All right, so that's a theoretical average. So consider this example, right? So this example is very important, right? So this is the first example we demonstrate the possible value of x, -505. And also we found their corresponding probabilities. All right, all these ones. And then we got the distribution. And based on this distribution, we can find the mean, right? The expected value. Sum of x and p of x, -5 times its probability 0.36. 0 times the probability 0.48. 5 times the probability 0.16. You see, this product, -$1. Huh, Tom? What are you doing here, right? So you are expected to lose $1 in a game, right? So you got to increase your skills, your free throws. All right, so now you're just what? 40% chance. 40% chance. You got to increase it by 50, 60, and so on, right? Oh my goodness. But it's already good. This shot is it's not easy, right? Anyway, so that's what we have, okay, for this example. Now, this example is a number of vehicles owned by randomly selected household from the certain region. So the possible value of x is 0, 1, 2, 3, 4. And wow, your families have 4 vehicles. That's a lot. Well, anyway, so the probability is 0.1, 0.2, 0.35, 0.25, 0.1, right? So the mu, the expected value is 0 times 0.1, 1 times 0.2, 2 times 0.35, 3 times 0.25, 4 times 0.1. Take their products and add them up. You got the number of vehicles. Now be careful, 2.05 vehicles. It makes sense because it is a theoretical average, right? It is a theoretical long run average. Okay, so if you talk about average, it can be a decimal point. All right, then variance and the standard deviation, right? So the variance by definition is this guy and also equals this one. All right, calculation-wise, this one is better. Standard deviation is the square root of the variance, the unit, right? Be careful of the unit. Unit of the standard deviation is the same as the random variable, but unit of the variance is the square of the unit of that random variable. All right, so for this one, we want to try figure out the variance and standard deviation given mu. Find that we use math two ways, right? Remember, those are two ways. So sigma square, method 1, you got that, and method 2, you use this one, you found that. Either of it works, all right? Just use whichever that you feel comfortable with. Okay, so now this one as well, right? So we already found that this is a 2.05, and then sigma square equals this one equals that, sigma equals this. All right, you know how to do it, right? So I use the second method two, right? So using this formula, okay. But it's really up to you. Okay, all right, so we're done with the second section. Now let's move on to section 3, binomial distribution. So for binomial distribution, we have this Bernoulli trial, right? So two possible outcomes. So one is called success, the other is called failure. And then this is for binomial distribution, is a sequence of n identical and independent Bernoulli trials with the same probability of success p. And then we say x is number of successes, then x is a binomial random variable with parameters n and p. So we have that. So these are the different examples, all right? Is that a binomial random variable? Guys, you got to determine, right? Is that yes or no? If yes, what's the coefficient? What is the number of n? What is the number of p? If not, why? Why is not, right? So we've got to figure that one out. So then the properties of the binomial distribution, right? So see about that. Binomial distribution parameter n and p, and this is going to be the formula, and then the coefficient is given here. Factorials are given, all right? Factorials. Wonderful. All right, so here is the calculator tips. How to use the calculator to find out the probabilities regarding to a binomial distribution. So we have probability x equals x, or probability x less or equal than x. These are two probabilities that can be directly found using the functions in the calculator, right? One is called binorm PDF, another is called binorm CDF. Okay, so we demonstrate this one using the following example, right? So this n is 10, p is 0.75, and we figured out all these probabilities, right? So this one, this one, this one, this one, this one, that one, that one, this one, right? So you need to be careful, especially for 3, 4, 5. Yes, so they cannot be directly found, but you can transform them into an expression for which you can use a calculator. Okay, very good. This example, right? So all these ones is going to be very complicated. You don't want that. You can use what? These formulas as calculators, right? And then this example. And to find the mean, all right, so you can do this. But as we see, there is a theorem. Yes, so this is a theorem. For binomial distribution, we have a formula for mean, formula for sigma square, subformula for sigma, right? So you can just directly use these formulas to find the mean, the variance, and the standard deviation easily. Okay, so this example, right? And this example, all right, do you speak English? Yes, you speak English very well, right? All right, so anyway, so you need to know what kind of distribution it is, right? In question 1A here, yes. You need to binomial distribution with parameter n equals 8, p is 0.2, and you can also do this. Okay, greater or equal than 1 minus that equals this. All right, find probability, the mean, standard deviation. Plug in the formula, you got it. Okay, I guess that's all for chapter 5. That's already for chapter 5. Now, we move on to chapter 6. Chapter 6 is about normal distribution. All right, so firstly, continuous random variable. All right, what is a continuous random variable? And then density curves. What do we mean by density curve, right? And then is the normal curve. It's a special density curve. Bell-shaped jingle bell, jingle bell, jingle bell. as a bell curve. Yes, that's a normal curve. Anyway, it's a bell-shaped, fading at tails. It's symmetrical about the middle, in the center, And okay, so here when mu is 0, sigma is 1, that's a standard normal distribution. All right, z is normal 0, 1. And of course, for normal distribution, 1 standard deviation above the mean, that's about 68%. 2 standard deviations above mean, that's about 95%. Okay. We have families of normal curves. Shifts, that's controlled by mean, location parameter. The shape, controlled by sigma. All right. Okay, so here we have the calculator tips to find the, okay, T83, 84, to find a probability like this, to find a probability like this, to find a probability like this. All right. So of course you can also use the online calculator as well, but in the exam you cannot, right? You can use a calculator. Okay, for this one, what we usually first need to do is to find out. All right, let me just change another color. Find out the value of mu and sigma, right? So if it is given in this form, the first one is mu, the second is sigma squared, right? So sigma got to take the square root of 4 equals 2. And a normal CDF, all right, normal CDF, all right, so use a calculator between what? 10 and 12.52, so lower, upper, mean, sigma. You got that. Greater above this one, so 10 to the power 99, 10 2, right? Plug in 0.1003. And this example as well. So first define the mean, standard deviation, and plug in everything. You got this one. All right. And this one as well, right? So mean, standard deviation, plug in. You got all these probabilities easily, right? So you can also draw the graph. Draw the graph. You see, centered at -1, centered at -1, centered at -1. Yes. So shade the corresponding area. Okay. That's section 1. Section 2 is about applications. Applications. Harmony underneath. Okay, I don't know. Golden. All right. That's a very interesting song. Golden. Anyway, so procedure for harmony. Okay, so draw a normal curve. All right, draw a normal curve. Yes, and shade the area over 180. All right, and then calculate the probability, and then what? State your answer. Yes, state your answer. Okay. So basically, that's how we solve probability normal curve problem, right? Draw this normal curve, shade the area, and calculate probability, state the answer. And we did this example as well. We got this example as well. We got this example is skipped. And okay, now we move on to section 3, working backwards. All right, remember that if you walk backwards on a beach, when you turn around, you didn't see your footprint. Why? Why? Because you are walking backwards. You said this one in class. How do you know? Right now, we all know this. It's just walking backwards. Anyway, we got it. A normal curve, yes. So how do we do that? So here is the procedure. Step 1, find the percentage, find given the information, find the area below that cutoff value. So that's the step 1, find the percentage below the cutoff point. All right, so then using the even norm to find this one. So enter, right? Second distribute in norm P mu sigma, enter, and state your answer based on the question. So we did multiple examples for this. But first, you got to figure out what does it mean, what is the standard deviation, okay? So once you got that, everything P below, right? So you got to be careful. All right, you know what? I believe this is again similar. All right, so in the other lecture notes, okay, find that one. That one is also good. All right, so basically these are the examples we did. All right, so okay, all right. This is about come on. All right, so remember this one. This one is that we skip this one first. This means this one is not included in, is not included, all right, is not included in the exam, right? We skip for now, right? Skip it for now. So don't worry about this one for now, okay? So now let's go on to final chapter 7. All right, final chapter 7. So chapter 7 is only the first section, all right? Section 7.1, central limit theorem. You only need this one, all right? So for this one, you have the central limit theorem, all right? Central limit theorem. So X bar is, okay, all right. So, well, you need to, firstly, it is a random sample. And then what? N should be greater or equal than 30, all right? Then we have this approximation. All right, X bar is about normal with the same mean, the variance is sigma squared over n. All right, so this is important. Okay, so let's consider this example, right? So we did this example. Oh, why there's no my solution here? Anyway, that's fine. So for this one, you see that it is a random sample, right? So random sample of size what? N equal to 30. Now 30 is greater or equal than 30. So satisfy that condition. So by CLT, right, X bar is normal with the same mean, which is 24.43. That's sigma squared over n. Sigma squared is 2.20 over n. N is 30. All right. So approximately. Now, based on that, we know the mean for X bar is 24.43, and the standard deviation for X bar is square root of 2.20 over 30. All right, so now once we have the mean and the standard deviation, so you can find a probability 24.17 less or equal to X bar, less or equal to 24.82 is going to be normal CDF, right? 24.17, 24.82, mean is 24.43, and standard deviation square root of 2.2 over 30. And using the calculator, you got that value. All right, you got that value. Okay, similarly for this guy, yes. Now this one will be what? Normal CDF, 23.4. This is going to be what? 10 to the power 99. Yes, there's no upper bound. So 24.43 and square root of 2.20 over 30. And using the calculator, you find this one. All right, you found it. Okay. Very good. This is very good. And this example. All right, so solution as well. See, this is a random sample with a size n equals 100. Yes. Now based on this, C. Oh, my is C, L, T. Yes. And then we have what? X bar has a normal distribution with the same mean is 30. And the variance is 3 out of sigma squared over n. Approximately. All right, approximately. All right, so once you have that, you can figure out all this using the calculator. Right, of course, you need to use the mean of x bar is 30. Sigma x bar is the square root of 3 over 100. And then go here, yes. So that's how we got it. All right, I believe that is all the coverages of this exam. How do you like it? Let's give Dr. Z a round of applause. Let's give all of you guys a round of applause. Anyway, we're done. We're done. All right, so we're done with the review for this exam 2. All right, starting from section 4.4, right? And all chapters in all materials in chapter 5. All right, and then it's going to be the chapter 6 without the section 4, right? And then finally is going to be what? Chapter 7. Yeah, chapter 7. Section 1 in chapter 7. Okay, very good. All right, so this is about the review for the final for the final exam. All right, so now before I let you guys go, we also have to do the quiz. All right, I think we not this one. Sorry. Quiz. Okay, anyway, so I'm gonna get a quiz on a separate video then. All right, so don't worry about it. Now let's consider all the homeworks, right? So for the homework, 4 is going to be just the very bottom question here. All right, so for question 38 of this one. Now you can use the table if you want, but you can also use the method we discussed in class, right? The law of total probability, the basis theorem using the formulas. You can do 38 easily. This is actually a very similar question as one of the examples we did in the lecture notes, right? If they're not the same, all right, they're about the same, okay? Now let's consider homework 5, all right? Homework 5 is these questions here, all right? These questions in chapter 5, all right? These in chapter 5, okay? So now among these ones, all right, so you may consider this 2 is about determining whether it is a probability distribution. All right, so check out that. I think this is pretty obvious. All right, and chapter 5 is section 5. All right, given the distribution, find the probabilities. I believe you can do this. Right, it's pretty easy. This one, right? So x is the sum of the 2 rows. The possible value is 2 to 8, and we found all these ones. And this is actually one of the quiz problems we did. All right, so question 6. And then find the probability. We found that. X is odd. Yes. So very good. And 8, no more than 10 rainy days. Less or equal than 10. 7, 8, 9, 10. Plug in. 8 to 20 days, right? It's going to be this one. And probability number of rainy days at least 12. It's going to be just a plug in, right? So we have that. And question 11 is about a mean, variance, standard deviation. So we know how to do this, all right? So, and then the mean, standard variance, standard deviation. We know how to do this, right? Okay, the mean, standard variance, standard deviation. Okay, so we know how to do this. And here is going to be the binomial distribution, right? On the probability is about a binomial distribution. And find the mean, the variance, and and so on, right? So you can do that. Okay, so everything, I think this one is very, very similar to the examples we did in class. Okay, so that's for this one. And then chapter homework 6. All right, homework 6. There are 4 questions in homework 6. Right. So it's about normal distribution. And I found the following probabilities with mu equals that. And using calculators, you can find all these values. All right, double check with that. It should be straightforward. All right, this one. All right, so with the mean and standard deviation. So with the probably someone in the mid-career has annual salary greater than this one. So you draw the curve. Centered at 1, 2, 0, 0, 0, and 1, 2, 5 is 5,000 above that, somewhere here probably. And we want to figure out greater than that, and that's the area, right? So greater than that is normal CDF. This one, plug in, everything is given. Yes, so the probability stays the answer. Yes. So similarly for question 21, all right. So mean standard deviation, men's standard deviation, right? So your female nurse more than the average of the male nurse. So that's going to be for female nurse, and the mean is 55,786, right? So greater than the average male nurse, so that's 59. So you want to figure out this probability. So that's XF is greater than the average of the male. So you find that. Okay, the probability is this. If you're a male nurse, what is the probability that you make less than the average female nurse? So for, okay, well, you draw this curve for male is centered at what? Male is going to be 59686, right? And female is somewhere here, average for female. So the probability is less than that, equals this. All right, so be careful. This is for X male, and this is for XF, okay? So if you're a female nurse, what is the probability your salary is less than this? All right, so this is similar to so for female, the average is 55786. So 6,000 somewhere here. So that is what we have, and then you can find that, right? Similarly, if a male nurse or for male nurse, you need to draw the normal curves based on the male nurse. 59686. All right, so less than 6,000 is somewhere here, right? So, which is, sorry, 60,000. This should be 60,000. Okay, sorry, my bad. Okay, so in California, well, this is actually one of the quiz problems we did in class, right? So this is one of the quiz problems. It's question 22, right? Quiz problem. Okay, all right. So I think this is for homework. What? Six. Now let's just go to homework 7. All right, homework 7. You only need to worry about 2 and 5. All right, for this quiz, for this exam. Okay, so now for this one, all right. So A2 American workers 4.6, standard deviation 13.6, and so you want to see if X bar at the central limit theorem. We know that this one equals this, and 42 or randomly selected. Yes. So what's the probability? So mu of x bar, sigma of x bar, right? So then this one is about this. Okay. So if it's 37, then it's going to be the distribution like this, mu of x bar, sigma of x bar, and then this one is like this. For this example, the mean is this, and the standard deviation is given here. So what is the probability that random sample of 37 annual salaries have a mean salary between this, right? So this is distribution of the bar, x bar, mean standard deviation between that is going to be this. All right. So what is the probability that the random sample of 37 have a mean salary less than this, right? So x bar has a distribution like this. So mean standard deviation probability. I believe this is easy, right? I believe so. I believe. I do believe. Anyway, so that's about the review for this exam. Okay, someone called me. All right, should I pick up the phone? All right, I should. Right, it's late, but okay. All right, guys, that's about this exam review. I wish you good luck. And if you have any questions, please email me, and I will check my emails all the time, and we'll get back to you, as soon as possible. All right. So again, thank you very much, and I'm looking forward to the exam. I hope you too. All right. See you next Tuesday during the exam. Good luck.